This conference will now be
Technology. I am very happy to
recorded.
welcome all the participants from various institutions for webinar on industry-based artificial intelligence. Today our resource person is Mr. Raja. We are very happy to welcome you for webinar and thanks for accepting our invitation and being here for this webinar. It is my pleasure to introduce our resource person, Mr. Raja. Currently, he is working as a senior associate at Cognizant Technology Services, Chennai. He has around 11 years of experience in the information technology. As part of his assignments, he has been in Linux, AIX, shell scripting, Oracle PLSQL, Crystal report development, SQL Server, and Teradata. He has an experience on software development methodologies and worked on all the phases of software development cycle, which includes system study, analysis, design, development, and testing. He has worked on projects for clients such as Royal Bank of Scotland, Cargill and JP Morgan Chase Bank, and Standard Chartered Bank. Once again, I welcome you, sir. Dear participants, kindly follow the instructions which is available in the chat box, such as please turn off your video and mute your microphone during the section. Post your questions in the chat box and answer will be delivered at the end of the session. Feedback link will be posted at the end of the session. On behalf of Lila Institute of Technology, once again I welcome you all for this wonderful session. Surely this session will be more informative and lively. So I hand over the session to our resource person. Over to you, sir.
Thank you, madam. So I'm Raja Perumal. So I'm part of Cognizant for uh, past 8 years. So can you hear me, right?
Yes, sir.
Yeah. Okay. Thank you. So today, we are going to see about that, artificial intelligence, how it is effectively used in the industry. So if you know that, so most of the companies are they are migrated from their legacy system to artificial intelligence applications for improve their product quality and other enhancement features. So today, we are going to see how it is effectively used in the industry. So in this webinar, thank you for this wonderful opportunity given this opportunity, this session. So in this session, we are going to see about various parts of that learning technologies and methodology. So once again, let me go to the next one. So agenda of session is we are going to see about what is artificial intelligence and why we need to go with artificial intelligence, then machine learning techniques and deep learning techniques and data science. So finally, we are come up with how this real-time industry, this artificial intelligence applications are working. So based on some real-time use cases. So this is the agenda of this session. So artificial intelligence, it's a composition of machine learning and deep learning. So machine learning is a subset of artificial intelligence, and we have many algorithm based machine learnings are available. So there are three categories. We will deeply discuss on that each and every category in upcoming slides. Likewise, deep learning, it's also nothing but neural networks. So neural networks also is having three kind of technology techniques, so we can detailedly explain what is all about and how it is used in this real-time applications. So what is artificial intelligence? So it is science and engineering to making that intelligent machines, which means that we are trying to create a machine to perform as like human expertise. So that is that objective of artificial intelligence. So we are trying to mimic that human behavior, such as learning and analyzing and based on that learning, and it is provide the solution for given problems. So based on our software program designed by us. So this is all about that artificial intelligence program. And so it is based on that whatever knowledge we are feeding to that machine, based on that it is react. So if you look at this diagram, so one person is stuck in that earthquake. So what human is doing first, even though many parts are there, so first we are giving preference to human lives, and likewise we train that machine to do the same activity. So this is all about artificial intelligence. So here, goals of artificial intelligence. So we just want to transfer that human head expertise into software programs. So what are all the, so in real-time situation, so what human is thinking, the same kind of methodology. So we are feed that information into machine to perform the same kind of activities and give a solution. This is a objective of the goal of artificial intelligence. So here how machines are working in a real-time environment. It is based on that extensive knowledge of the real-time data collection. So whatever data collection from the real-time environment, it is understand what is the data and how it is related with each other, and situation, properties, events, cost, likewise. So based on that, it is correlated each other, and finally it is providing that expected output as like human expert. So this is the goal of that artificial intelligence. So knowledge engineering, it is a process in artificial intelligence. So it tries to emulate the judgment and behavior of human expert in a given field. So here, a process to understand and represent human knowledge to be fed into that machine. So that will be stored as a knowledge base. In the real-time scenario, so whenever artificial intelligence application is facing that scenario, it is referring the knowledge what we feed it into the program. Based on that, it will decide that outcome. So in this knowledge engineering, so we have multiple phases: knowledge acquisition and knowledge representation, knowledge validation, inference, explanation, and justification. So knowledge acquisition means we are collecting various knowledge from the multiple domain experts, how they are handle the situation in real-time scenario, and those information to be feed into the system. Based on that, some data structure, semantic layer, which means that what is the control flow and data flow, how it is objects related to each other, and likewise it is it's a series of process, and we feed into the machine. Based on that, the machine will give that accurate results. That is the objective of this knowledge engineering. So based on that knowledge, whatever we have given, so then machine will validate that. Based on that, it will it will conclude that it will give that idea. So this is for this problem, this may be the solution. So and what basis that solution is arrived. So based on some explanation and justification, so the machine will provide that. So anyhow, this is that iterative process. It is continually happen until machine will give that accurate results. Likewise, this knowledge engineering functionality is working in artificial intelligence. So why we go for artificial intelligence? So AI machines are very useful in disaster situations. So as you are aware that today we are locked down due to that COVID pandemic. So every world is locked down. So if you look at then some of the newspapers, we could see how this artificial robots are serving that COVID patient. Even doctors cannot able to they cannot connect each other frequently, but this AI machines is feeding, it's giving food and doing such kind of activities. So likewise, it is very useful in the disaster situation. And normally this AI program is giving that faster and accurate results. So if we anyhow, if we manually do perform some operation, we may have some careless mistakes and other things. So to avoid this one, since AI machines always provide accurate results and faster results. And nowadays, most of the companies are migrated their environment into AI technology to reduce, human efforts. So mainly on that, some repetitive task performed by human can easily handle on, AI application. So to do this, they are, most of the companies are using, AI technology and getting that, efficient and faster results. And also this AI is providing new possibilities and promote new growth in business. So this is also one of the major impact of AI to be there in all the environments. So nowadays, most of the companies are spending most of the significant amount of investment on AI and improve their product based on that user satisfaction and feedback and trends and more on. Based on that, it will improve the product quality and provide that best customer service. So these are all the reasons we are going for AI. So what are all the real-time applications of AI? So as we discussed that, extensive support in medical industry and detecting security threats and frauds in financial institutions, resolving user problem through automatic call center. So some years back, if you're calling to call center, so the recipient will be that human. The recipient may be the human, but nowadays if you call to any call center, the recipient may be the IVR system. It will automatically en route what we really require. And likewise, this kind of AI application is really helpful in real-time environment. So then automating repeatable tasks such as payrolls and data entries, audits and other things. So these are all the things so we cannot able to help with human because repeated tasks. So for that artificial intelligence application is providing more efficient way of doing this kind of repeatable task. So anticipating user actions and providing recommendations. So if we are going to that Amazon application and I'm going to order some of the product, and the machine automatically gives some feedback saying that these are all the related product, you can buy that only. So likewise that AI machines it's provide that feedback and recommendation. Based on that it will improve their productivity. So likewise this real-time this AI applications really helpful on real-time environment. And managing social media comments also one of the real-time application of AI. So not only this one, so this AI artificial intelligence applications are much more working most of the fields. We'll see one by one in various layers. So next one is machine learning. So why we need to go to machine learning? So prior to machine learning, so artificial intelligence program having some limitations and restrictions on their program capability. To improve that, we are preferred to go to machine learning. So in initial days, AI program is doing very low-level task and low-level automations. And so this AI programs also is very domain specific. To overcome these limitations, we are going ahead with machine learning. So what is machine learning? So it is a study of computer algorithm that improve automatically through experience. So this is all about that machine learning. So also it is a subset of artificial intelligence. So what is machine learning algorithm is do? So we are going to build that mathematical model based on sample data and training data in order to predict and decision without being any programs. So likewise we are going to apply mathematical logic in this machine learning to provide accurate result on real-time environment. This is all about that machine learning algorithms. So we will detailedly discuss about that machine learning one by one. we have three kind of machine learning techniques are available in. So first one is supervised machine learning techniques and unsupervised machine learning, semi-supervised or reinforcement machine learning. So supervised machine learning, it is all data is labeled and algorithm learn to predict that output based on that input. So we will discuss we will detail discuss in further slides. So likewise, unsupervised machine learning is based on that data is not labeled, the unlabeled data, and we are trying to approach some algorithms, and based on that objects and other things available in the data, it is grouped together and create some clusters. Based on that, it will give an output. So we will see some real-time examples in upcoming slides. Then semi-supervised machine learning. So for this, we have feeding some labeled data or unlabeled data, and using some supervised and unsupervised machine learning to provide to predict that problem solving. So we will go detail in further slides. So supervised learning. So we label data, train the model. So first, here, set of, objects we are feeding to that, machine, and here, what is feature of that object, those information we are giving to that machine to learn. Based on this technique learning, so what, so if the input data is coming, that test data is coming, square and rectangle, based on this learning, so that system is predict that right output. So likewise, it is working on this supervised learning. So collecting features and label of the object, and modeling algorithm used to predict and categorize based on the features associated with the label. And finally, it is provide the record output. So in real-time example, suppose if we feed height and weight of the person, based on that height and weight, we can able to categorize whether that person is fatty or fit category. So likewise, this supervised learning to categorize the input into our required format. So this is supervised learning. So next, we are going to see about that unsupervised learning. So it is processing an unlabeled data, and what machine will do based on some algorithm, it is grouped together. So based on some objects and related with other objects, and categorize the data. Finally, it predicts the required output. So if we look at that real-time scenario, we are feeding that cricket scorecard as a data set. Cricket scorecard is not a labeled data, it's unlabeled data. So based on that machine learn, and this an algorithm is learn and categorize who are the people are highest run scorer, and who are the people are highest wicket taker. Based on that, it is categorized into two clusters and provide the results. These are the persons are performing well in runs. These are the persons are performing well in bowlers. Likewise, it is categorized. So likewise, this unsupervised learning are working in machine learning techniques. So semi-supervised learning. So it is a mixture of labeled and unlabeled data. And so whenever we feed that image to that machine to predict that, so machine is based on that required ability and algorithm, it is predict one results. If that particular results are not matched, we are giving the negative feedback so to that particular output. Then again it is refined, and it is collecting the related inputs, and based on that it is predict the right output. So this is nothing but a semi-supervised learning in a machine learning technique. So if you look at that this example, so we are giving that dog image, that machine will predict this is a cat. Then we are giving that a negative input saying that it is not a cat, it is looks like dog. Then this machine will learn all the features related to dog. Based on that, it will predict that image input image as a cat. Likewise, it is learned in semi-supervised learning is working in machine learning. So there are multiple machine learning algorithms used in various categories. So linear regression, So if you look at supervised machine learning, so the linear regression, decision tree algorithm, so random forest algorithm. So if it is unsupervised learning, appropriate algorithm, k-means algorithm. So if we look at that semi-supervised learning, so Markov prediction, Markov decision process. So this one I'm going to explain in a real-time scenario in last. Okay. So what are all the real-time applications of the machine learning? So if you look at that, supervised learning, again, it's further classified into classification regression environment. For classification, it is used to image classification, customer retention, diagnostics, and identity fraud detection. So likewise, these are the applications are really used in this, supervised learning. Again, the regression environment, advertising popularity prediction, weather forecasting, market forecasting, estimating life expectancy. So likewise, these two categories, these are all the real-time application belongs to the supervised learning. If you go with that, unsupervised learning, so clustering, so recommender system, based on that, input data, it is, recommend based on, as like that, Amazon up. So targeted marketing, customer segmentation. So if you look at that, dimensionability reduction, meaningful compression, big data visualization, structure discovery, and feature elicitation. So what are all the application belongs to reinforcement learning is real-time decisions, robot navigations. So real-time decision in the sense, based on that previous experience, we are going to predict that future future decisions, future status, and predict that accurate results. So that we are going to do it in Markov model. So then learning task. Hello. Then learning task, skills acquisition, and game artificial intelligence. These are all the real-time application belongs to that machine learning. Then deep learning. So deep learning, it is also called as neural networks. So deep learning is how human behaviors are thinking on real-time problems. Based on that, we are mimic that that kind of network, that kind of architecture in deep learning methodology as system to be think like human. Likewise, so in deep learning is an AI function that mimics the working of the human brain in processing data to use in decision making. And so it is processing both structured and unstructured data. So again, the deep learning, so it is categorized into three parts. So artificial neural networks, and convolution neural networks, and recurrent neural networks. So convolution neural networks, it's especially used on image recognition and image classification, and object detection and recognition cases. RNN is mainly used for that, time series application, and a series of repeated operations are done over and over on set of data. So first, we need to go to explain that, artificial neural network. So it is based on the structure and functionality of biological neural networks. So human brains normally has that millions of nerve cells called as neuron, and it is connected with axon with other cells. So likewise, artificial ANN is designed like that. There are three layers are involved here, input layer, hidden layer, and output layer. So here that's ANN nodes are taking input data as a futures from data set, and perform some simple operation prior to send to that next level. So actually what happened, so nodes are normally is interrelated, connected with other neurons by links. So if you look at this, one neuron is connected to all the neurons which is available in the hidden layer. likewise. Here there are some pre-process happening at input layer itself, and nodes are interacted with each other, and so it is here there are multiple links are there. So each link is associated with so weight to be assigned. So based on that weight is multiplied with input and given as a output for this neuron, this hidden layer. Likewise, these kind of pre-processing are happening in neural networks. So normally this output value is nothing but node value or activation value. So in hidden layer also there are some pre-processing techniques or pre-processing approach are happening based on some algorithm. So finally, so based on some probability, so the outputs are arrived. So here hidden layer may be n number of layer. So output layer normally is categorized based on some probability. So highest weighted sum on each link, so will provide that required output and accurate output. So that is all about that ANN. Here we are using some activation function to identify this this neurons and pre-processing techniques. So there are famous activation functions are used, binary stub or sigmoid activation functions and tanh activation function and identity activity function. These are all the famous activation function are used to predict the data. So this is all about that artificial ANN. So then we will see about how it is used in the real-time applications. So most of the ANN applications used for handwriting recognition and traveling salesman problem and image compression and stock exchange prediction. So these are all the real-time application for ANN artificial intelligence. So next we are going to see that recurrent neural networks. So here so best example of recurrent neural network is so if you are giving some input to Google Assistant, and then whatever input we are giving as a speech as a text, so based on that particular system is predict what is that requirement. Based on that it is giving the required output. So say for example, so I'm asking what is the weather outside in Google Assistant. It will predict my requirement. Based on the requirement, it will give you that it will provide the right output. This is the forecast for today. Likewise, so this technique is nothing but a recurrent neural network. It is processed whatever data we are giving, it is processed one by one, and finally it will predict that required output. So here in traditional RNN, all the inputs and outputs are independent to each other. But so predict that next word, the previous word is necessary. So for that what has happened, so every previous output to be passed as an input to that current input. So this is the main thing we need to consider in recurrent neural networks. Sequence of word or data to be passed in this input, and previous layer output passed to the current layer input. So that is also a main thing to be considered here. So in natural language processing, so suppose how it is working. So what I'm speaking, so I'm speaking with system, so it will convert my speech into the text based on that backup words and some texting algorithm. So after that it is converted into vector. So when we convert that text into vector, so based on that it will apply that algorithmic logic to predict that what is that requirement, what is that what is the solution for that. Likewise it is using them. So here there are pre-processing techniques are available in this RNN. The backup words and word to vectors are used to convert the word into vectors. Likewise, it is designed to working on that. So mainly, so this RNN is used on that speech recognition and language modeling and translation and machine translation, weather forecasting and time series. So suppose we have, so I just want to predict that what is that forecast for that next quarter. So based on that current data and previous data, based on this, it will provide that accurate results in time series applications. So also that weather forecasting also it is doing accurate weather forecasting. So these are all the real-time application in RNN. So next one is convolution neural network. So convolution neural network, it is mainly used on image recognition, object detection, object classification, and object recognition. So normally that input file may be that images. So what will happen in RNN? First, when we give that image, so it is classify the visual content and so recognize the object. So what is nose, what is eyes, what is lips, ears, face. Likewise, it is each and every category is divided as every feature and given as input to that in the input layer. So then, so all the we gathered all the recognized object into clusters. So eyes with eyes and ears with ears. Likewise, it is form the clusters. After that, we have 4 layers on convolution. So this CNN approach. So convolution layer designed to identify the features of images. So what is the shape of the features? Identify the elements of an object and face. And so if it is if you look at this cat space, we can able to find that edges of that particular cat image. So based on that, we are going to filter out that particular thing, and we need to use to identify what this is. Likewise this convolution neural networks is working. So another layer is rectified linear unit layers. So applying some filter to striping an image of excessive pattern to provide better features. So likewise, we are applying some filter and identify one by one. So likewise, this convolution neural networks is working. So next one is a pooling layer. It reduces the number of parameter by which it can concentrate on meaty parts of the received information. So finally, so the system is assigned the related features, and finally it predict that what is this will be that output. Likewise, it is decided based on that processed with some algorithmic logic. So this is nothing. So these kind of techniques are used in this convolution neural networks. What is the real-time applications are working in this CNN? Image classification, so face recognition application, and legal, banking, insurance, document digitization, and medical image computing, and healthcare data science, and prediction analysis. So these are all the real-time applications of CNN. So next we are going to see about that data science. So what is data science? We are going to use all the AI and machine learning and deep learning techniques in a real-time use case with the help of math applications and provide that required output. This is all about the data science. So we can able to see that various layers are involved in this data science. So first one is business understanding. So in this layer we are understanding the business so what is the real-time use case, and we need to understand what is really required, and based on that it is going to that data acquisition layer. So we are collecting various data from various data sources. So whatever data we are collecting, so we need to clean that, we need to analyze the data, and we need to remove that unwanted data here in data acquisition and understanding layer. And so modeling layer, so we have that feature engineering. Feature engineering is nothing but handle the null values and formatting the right set of data, which is really required for that modeling, and applying some normalization for that data. So these kind of activities are performed in feature engineering. So once that is done, so we are we are selecting the right model to process that particular use case particular data. So once we apply that one, so finally, so that required output will be deployed in production environment. So if the customer is not satisfied with that, again, so the deployment, so in which phase is not satisfied, it is again in this going back to the modeling stage or data acquisition stage. In some cases, it is going to that business understanding stage itself. So based on that, what kind of data is required, it is not related to that, it is going to the data acquisition and understanding state, and we refine the data and getting some more data related to this particular use case. Likewise, it is this data science is working. So what are the real-time applications of this data science? Fraud and risk detection in financial institution, image and speech recognition, healthcare environment, augmented reality, and airline route planning. So these are all the major application in data science. So what are the requirements, prerequisite for AI programming? So we need to familiar at least one language. It is very well and good for doing that data science project and AI projects. So normally, so right now, so in industry, so they are concentrating on Python to provide that AI programming, and because most of the libraries are available in Python to improve to coding what we are converting into programming language. So R programming also is very easy to learn. So this Python and R is very easy to learn and easily coding into that on this machine language and deep learning techniques. So Java. So in our use case, we use Java for Markov prediction algorithm. So Java also is very useful to coding on this AI programming. So mathematic tools is very, very important. So we need to have the probability and the linear algebra, differential calculus, and these are all the major techniques are used in this mathematical tools. Based on that, we are going to apply this algorithmic logic into program to provide the better results. That is all about this this AI programming. And finally, the statistics. So we need to, statistics are very, very important, because based on that statistics, we are going to giving the better results. So these are all the prerequisites for AI programming. So now we are going to discuss about that what is real-time use case of the Markov prediction algorithm. So nowadays, in client environment, so most of the people are connecting through virtual machines. So for that, handling the multiple virtual machine in a single server is it's very headache, and CPU utilization is a very challengeable thing. So here my problem statement is in cloud environment, multiple servers are residing in it, and each server multiple VMs are available and utilizing the CPU utilization. In some cases, some of the VMs are utilizing more CPU, so it will create a problem in that environment, and other VMs also impacted due to that. So how do we predict and how do we resolve that problem based on this? So by using Markov prediction algorithm, so we are going to give a solution. So here, step-by-step process. First, we need to collect the data from various cloud environment. So how much data are each and every VMs are consumed in the near past. So based on that, we are going to predict the next date, which are all the VMs are going to take that, more data. Based on that, we are able to conclude, so what need to do in near future. Likewise, this, Markov prediction algorithm is working. So here, what we are doing it, first we are collecting all the information in the sense, CPU utilization information of each and every VMs from various servers in a cloud environment. Then we are categorize, those input into three parts based on that, threshold. So if that particular VM is overload and underload or normal load, based on that, it is, that input data is categorized into three parts. Again, based on the probability, again this state will be transferred into that, transition matrix. So here, if you look at this diagram, so there are three phases are there. So the particular VM, so how many times it is in a possibility to go from overload to normal load, likewise overload to underload. Likewise, based on this one, we are going to create a transition matrix from that, classified data. So then we are going to apply that, Markov prediction algorithm. So this is the transition matrix. So based on that input, we are categorized into three phases. Based on the three phases, we are, calculating how many times, each VMs are going to three different phases. Based on that, we are deriving this, matrix. So if you look at the underload to underload, underload to normal load, and underload to overload. Likewise, these different phases are, from that existing input, we are going to derive this transition matrix. On top of this transition matrix, we are going to apply this, Markov prediction algorithm, Markov first order algorithm, so that it will easily predict what is the next state of, each and every VMs. Mainly here, we are concentrating on which are all the systems are going to overload. So that system, we are going to, identify that, and we need to give a conclusion. Oh, these are all the VMs are going to overload in the near future. So based on that, the system will, conclude what we need to do. Either we need to, increase that, additional resources, or else, it will, and that system in the VMs will be swapped with another, server, which is, using that very low, which means that, underloaded process. Underloaded process means, in some of the servers are having very, usage is very less. So we can easily swap from one environment to other environment. So likewise, we can able to balance that, CPU utilization, or else, so if we want to add that additional resource to handle the overload, or else if some of the VMs are, long running process, then we can able to kill that. Likewise, this Markov prediction algorithm is, give that accurate results and identify the solution. Based on that, it will, provide the output. So initially, so we have, done this in Java program. So initially, so many challenges are there, identifying the data and categorizing the data. But when we apply that Markov prediction algorithm, so it was providing that, accurate results. So what is the use of prediction algorithm? It solves the resource management problem in cloud computing, and it increased that, revenue for the cloud provider, because, normally, so when we are using that, that VMs, there might be SLA. So based on this, we can be able to meet that SLA. So it will increase that, revenue of the particular company. So this is all about that, prediction algorithm we are used in the real time. So that's all about my, presentation. So if you have any questions, you can able to raise it now, so that, we can able to discuss further.
Thank you, Raja.
Yeah.
So there is one question. Can you please explain the types of artificial intelligence?
So normally that artificial intelligence are mainly based on that machine learning and deep learning techniques are used.
Thank you, Raja, for this wonderful section. This is time to give the vote of thanks. I request Ms. Rama, the Assistant Professor of CSE Department, to deliver the vote of thanks.
Thank you, ma'am. I feel elated to propose this vote of thanks on behalf of Loyola Institute of Technology. Hope you all enjoyed this section. I'm very glad to see the response of faculties and students from various institutions. I thank all the participants for participating in the webinar during the current situation. I would like to thank our management for constant support, and I extend my heartfelt gratitude to our principal, ma'am, Dr. Sujata Jamuna Anand, for her motivations. I thank Mr. Rajabirmal Sir, Senior Associate, Cognizant Technology Service in Chennai, for sharing his knowledge to make the session more lively and successfully. I like to thank my colleagues to make this event very successfully. Once again, I thank all the participants making this event grand success. Thank you. The feedback link is available in chat box. Kindly use it. E-certificate will be sent to all the participants after filling up the feedback link. Thank you once again. Thank you all.
Ma'am, I have a query with the resource person. Shall I ask him?
Yes, ma'am. Yes, ma'am.
Hello, sir. A very good presentation. I have a doubt. For example, if I have a data set, if I take an image processing, for example, if I take breast cancer, and if I take an algorithm, how will I classify that, whether it is an ANN or CNN or RNN? How should I distinguish, or an neural network? How do I say that it makes a difference?
Normally that image processing, so we are prefer to have that CNN, because it is each and every pixel wise operations are performed in CNN. So in current trend, so that in CNN is the best option. So how they are deciding, since so based on that previous experience, it will decide it.
Sir, it can
CNN
also be
is
done using neural network also, but it can also be done using CNN also. By what makes a difference between NN and CNN?
So actually, so here CNN the preferred one. So ANN it is based on that it is not familiar with that images. So this one actually this ANN is especially for that the speech recognition and other things. But CNN is especially for that calculating the pixels of each and every image. With that we can provide that accurate results. So that is that
Okay, sir.
all about it.
Thank you.